Hey guys, welcome to Pepcoding. So in this video we are going to discuss our new question of searching and sorting series, and that is chocolate distribution. So in this question we'll be given an array of positive integers n where each value represents the number of chocolates in a packet. So in simple way I can say I have n number of chocolate packets. Okay, I have n chocolate packets, and each packet containing number of chocolates is stored in the form of array. Okay, like the number of chocolates in that particular packet is stored at that particular index in the array. Okay, so each packet can have a variable number of chocolates. There are m students. The task is to distribute chocolate packets among m students such that each student gets exactly one packet. So say I have m students and I have to give each a single packet to every student. Okay, and the difference between the maximum number of chocolates given to a student and the minimum number of chocolates given to a student should be minimum. That is, the constraints are each student first of all get exactly one packet, and the difference between the maximum number of chocolates given to a student and minimum number of chocolates given to a student is minimum. So let's see how. What does it say? Suppose I have an array. It means I have 6 packets of chocolate and I have 4 students to distribute these chocolates among them, right? So first, let's say my first packet contains 2 chocolates, second packet contains 5 chocolate, third packet contains 1 chocolate, fourth packet contains 3 chocolate, and then my fifth packet contains 13 chocolates. All right, and my last packet, that is 6th packet, contain let's say 6 chocolates. Okay, so let's say if I have 4 students, so I'd say that I'll be giving the first packet that contains 2 chocolates to the first students, right? And second packet that contains only 1 chocolate to the second student, and fourth packet that contains 13 chocolates to the third student, and the fifth packet that contains 6 chocolates to the fourth student. So this is, let's say this is my one distribution. Now here, as you can see, the minimum number of chocolate given to a student is 1 in this distribution, and the maximum number of chocolate given to a student in this distribution is 13. This is min, this is max. Now max minus min is equals to what? The difference between them is 12. Right, because the difference between the max and maximum number of chocolates given to a student and the minimum number of chocolates given to a student is 12 here, which is a huge amount, right? So what we have to do, we have to find out such a distribution where this difference is least, right? So we have to return that least difference. Okay, so we have to find out that minimum difference. Now if I again say I have another I have another distribution. If I say I give a packet containing 2 elements to the first student, packet containing 3 chocolates to the second student, packet containing 6 chocolates to the third student, and a packet containing let's say how many chocolates? Let's say 1 chocolate to the fourth student. Now the difference between the minimum and the maximum here is 6 minus 1, that is equals to 5. So the difference between the maximum chocolates given to a student and minimum chocolates given to a student in this distribution is only 5, right? Because the student having maximum number of chocolate has 6 chocolate, and the student having minimum number of chocolate has only 1 chocolate. Okay, so the difference here between them is 5. Now if I again say I have another distribution, here the difference was 12, here the difference is 5. Now if I again say I have another distribution, let's say that distribution is 3, 5, 6 and 13. Minimum is 3, maximum is 13, difference will be equal to 10. 13 minus 10, that is 13 minus 3 is equals to 10. So here the difference is 10, here it's 12, here it's 5. So the minimum is this. Okay, so we have to return this minimum. Okay, this minimum difference that we can minimize, like this minimized difference. Okay, so that we can say we have such a distribution where the difference is minimum. Okay, and that minimum difference is 5. Okay, so let's see how we can do this. Let's suppose if I have an array for 4 chocolates containing 7 chocolates, 13 chocolates, 1 chocolate, and 8 chocolates, and let's say it has one more chocolate, that is it has 3 chocolates. Okay, I have m is equals to 3. I have 3 students. Okay, I have to like distribute packet to I have to distribute single packet to all these 3 students. So let's say if I say first, let's say my first distribution will be 4 7 13. Okay, so it is on the first, second, third. Now again if I say second distribution of mine can be 4. Let's say this is the first student, 4 4 7 8. Okay, now my third distribution is equals to, this is my first student, this is my second student, this is my third student. Let's say I can say 4 7 and 3. Okay, so or and again once again I can have another distribution that can be 4, that can be 4 3 1 4 1 3. Okay, 4 1 3. Now here the difference is 3 minus 4, that is equals to 9. Okay, now the difference here is 8 minus 4, that is equals to 4. Difference here is 3 minus 7, that 7 minus 3, that is equals to 4. Now here the difference is 4 minus 1, that is equals to 3. Okay, so the difference here is minimum, so we have to return this minimum difference. Now from here, as you can see, if I sort this array, let's see, if I sort this, I get such array that is 1 3 4 1 3 4 7 1 3 4 7 8 and 13. Okay, this is my array, sorted array. Now if from here I can simply make groups of 3 3 and then find out the distribution, right? And then find out the max minus minimum. Let's see how. If I pair this, if I have the first pair like this 1 3 4, max minus min here is 3. If I say I have 3 4 7, if I say I can I do this 1 3 7, so the difference max minus min here is 6. 1 3 8, difference here is 7. Now 1 3 13, difference here is 12. So from here, as I can see, if I sort this array and if I take take the packet containing only one chocolate as a minimum packet, as a packet that has minimum chocolates, if I take this one as the minimum, then I can only have 4 as my max, so that I can get the minimum answer, right? So this sorted array helps me, so that it shows me that I have to reach to only this index, that is equals to m plus I, right? I plus m, that is 0 here. 0 plus m is 3 minus 1, because it's indexing, so it will be I plus m minus 1. Okay, so I have to reach only here, and this will be my optimal answer for this combination. 1 3 7. If I choose 7 instead of 4, it gives me 6. If I choose 8, it gives me one more answer, that is 7. If I choose 13, it gives me one more larger answer. So I just have to make this only sorted, this only frame for keeping 1 as minimum. So only the 4 can be the maximum value for this one. Okay, so that it gives me the minimum answer. Okay, because I cannot take 7 8 or 13 as maximum. When I take 1 as minimum, my 4 can be the only maximum answer that gives me the minimum difference of max minus min. Okay, minimum value for max minus min. Okay, right? Because I cannot take 7 8 13. So here my sorting helps me. My array looks like this, so I just have to make a frame of this I plus m minus 1 from index I till n minus 1. Okay, and I have to just subtract this, so I can find the max minus min. So this is my first distribution for 1 3 4. Now if I again say, I again have a distribution for this, let's say this 3. Now if I make a combination of 3 4 7, it gives me the difference here is equals to 4. If I make 3 4 8, difference here is equals to 5. If I make 3 4 13, the difference here will be equal to 10. Okay, so here also this 7 can be only my maximum when I take 3 as my minimum, right? Here also I have to just add plus m to my index and then minus 1, and that till that particular index I form my window and then find the maximum, like find the minimum difference of max minus min. Okay, now again for the 4, let's erase this, let's erase all this. Okay, yeah, now come here. Okay, let's take another color. Yeah, again make my sorted array. Let me make my sorted array first. That is 1 3 4 7 8 13. Okay, this was my sorted array. All right, so now for this 4 I have to make another frame. So when I take this packet containing 4 chocolates as the minimum packet, so my maximum can be, when my maximum is equals to 8, I get the minimum value for max minus min, right? Because when my distribution is like this, 8 minus 4 gives me 4. So when I take 4 as my minimum, so when I make it 13, it gives me even more answer. 13 minus 4 is equals to what? It is equals to 9. So this is my optimal value. This gives me the minimum value for this max minus min. So it is again equal to I plus m minus 1, right? ARR of I, like this value is I plus m minus 1. Okay, so the element at index will be index I plus m minus 1 will be my max for this value 4, right? So that it can give me the minimum value for max minus min. Okay, now again for 7, let's again check for 7. For my 7, I can have a distribution of, like the max index for it will be what? 7 is at index 3, so 3 plus 3 is equals to 6. 6 minus 1 is 5. So at index 5, what I have? 13. So here 13 minus 7 is equals to what? It's equals to 6. Now from here I can not have any other combination for, so when I take 7 as the minimum, so my 13 will be the maximum. Okay, so that it can give me the minimum value for max minus min, right? Now if I make another frame for 8 13, I cannot make frame for this 13 also, 8 also. I cannot take this 8 as min. All right, so because for that I do not have any other max value. I can make any combination. Let's say I can make any combination as 8 to 13, but I have considered it 2 as min already. I have calculated this answer for, sorry, I don't have 2. Let's say 8 3 13. I have calculated the answer for 3 already, because when I take any elements from here for this to make this distribution, I have already considered this, then this element become the minimum for me. Okay, so I have already calculated the minimum answer for this. Okay, when I take this 3 as a minimum, I have calculated my answer already for this. Then my 7 will be maximum, right? For my 3, the 7 was the maximum value that can give me the minimum value for max minus min. So I am not going to take any value from here. So I can only make, how many windows will be there? There will be only what? N minus m plus 1 windows. Okay, n here is what? 6. M here is 3. 6 minus 3 is 3 plus 1, that is equals to 4. So here we will be making 4 windows. Okay, so first of all we have to sort the array. First of all we'll be sorting the array, and after that sorting, what we'll be doing, we'll be making n distribution. After that sorting, we'll be making n minus m plus 1 windows, and for that window we have to just calculate the difference of ARR of I plus m minus 1 minus ARR of I. Okay, right? This is, let's say this is my ARR of I plus m minus 1 for when I is equals to 0, and this is my I. So I just have to calculate the difference, this minus this, right? And again for this frame I will be calculating again this, that is ARR of I plus m minus 1. That is, this is the max for index I, and ARR of I, this is the min, है ना, right? And then update my min value. Now again for this, okay, so we just have to return the min value for such a distribution, min value of max minus min for some distribution, right? So let's just try to code this. All right, so first of all what we have to do, first of all we'll be sorting arrays dot sort ARR, and then I'll be making an answer. Int answer is equals to integer dot max value. Okay, now we'll be running a loop. Simply I run a loop for int I is equals to 0. Now we have discussed this loop will work till which position? N minus m, right? loop will work from 0 till n minus m. We have discussed that this will work from n minus 1, n minus m plus 1, but from here we are starting our index from till 0, so we don't have to minus 1 here. Okay, so it will run from 0 till n minus 1. Okay, now I plus plus 1. Now what we have to do, we just have to answer ARR of I plus m minus 1 minus ARR of I. Alright, and return answer. Now let's return the answer and let's try to run this. Okay, accepted, and let's try to submit this. What's this? It's giving me an error. Okay, so the server is there is some error on server. Okay, so there is some server error, but my answer is correct. Okay, so you can try to code this and submit this on the portal some other time, because it's showing me server error, but I'm sure that this answer is correct. So let's again try to submit this. It is showing me server error. Okay, submitted, right? So I hope I made it clear to you. So I hope you like this video, and if you like this video, please like, share and comment, and thanks for watching.